All right, so today is Tuesday the 14th. We're going to work on the warm-up. We're going to finish the notes on causation. And then we're going to work on scatter plots, lines of best fit. I'm gonna staple and give you the study guide for you to go ahead and start looking at it. Okay. So this is what I want you to do tonight. I want you to go through and only do the problems that you know for sure you know how to do. That's what I want you to do in the study guide first. Okay. Go through and do everything you know how to do first. Any questions about that? Okay. All right. Let's work on the warm up. I'm gonna pause for the calls. I'm gonna leave it here for a second because people are still writing, and I'm gonna go ahead and pass out the study guide. I need you to work on the warm up. Okay. Okay, good folks. Let's look at the warm up. Let's see how you did. Okay, look at what it's saying. It says we'll write an equation. The equation we're gonna write is in slope-intercept form. What's slope-intercept form? What? Go ahead. No, it's fine. Go ahead. Y equals mx plus b. Good job. Okay, that's slope-intercept form. So we're going to write it in that form. And we're going to, it says of the line that's perpendicular to this graph right here. And it passes through this point. Okay. All right. So if it's perpendicular, what does that mean about the slopes? Yes. They do cross. Perpendicular means that the lines cross to form four right angles. But what's the difference in the slopes? Yes. Opposite reciprocal. So if the slope of this line, what is the slope? What's the slope of this line here? -5. So then what's the slope of the other line going to be? What is the slope? Yes. 1/5. So this is the slope that we're going to use for the other line. Let me move this stuff out the way. Okay, raise your hand if you got that part right. Okay, only one person got that part right? Okay. Y'all gotta go back and look at your notes. Okay, you really do. Because I know for a fact that's gonna be it should be on the quarter test. It should be. Okay. All right. So let's look. Next thing. Now we have found our M. So in order to write an equation in slope-intercept form, you have to find B. Okay. Does anybody remember how to find B for the other equation? Yes.
Use the coordinate and you label the coordinate X and Y.
Okay. Use the coordinate and label the coordinate. This is X. This is Y. Perfect. What else?
And then you use the Y as the Y and the Y equals
And what form? Y equals mx plus b. That's what I was looking for. Thank you, babe. And the 2. Very good. So you're going to substitute this information here. Okay. So your y is -1. Your m is 1/5 times your x is 2. Write it as a fraction. That's 2/1. This is plus b. Any questions about that? Okay. So now we're solving for b. Bless you. We're solving for b. So this is -1. Multiply straight across. This gives you 2 on the top, 5 on the bottom. Okay, we did this. We got plus b. Okay. So now we're going to get b by itself. How do you get b by itself? Yes.
You would subtract 2/5 from both sides.
Very good. You're going to subtract 2/5 from both sides. Okay. All right. So when you subtract 2/5 from both sides, what is this going to give you? A negative what?
-1 and 2/5.
-1 and 2/5. Bring down the equal, and this is b. So now you have m and you have b. So how do I take this information and write it as an equation that's written in slope-intercept form? Because that's what they're asking for. How do I write the equation now in slope-intercept form? Anastasia?
Y equals X minus 2.
Very good. Yes.
Wouldn't it be 3/5? Wouldn't it be
Where you get 3/5 from?
no?
I think he subtracted 2/5 from the -1.
Well, we didn't subtract because it's minus. Yeah, so that's okay. So he subtracted. That's where you got that from. It's not.
No.
That's okay, babe. Any questions? Is everybody okay with each of these steps? You got to be able to do this on your own. So if you have a question, you need to ask. Hatcher, are you good? Okay. All right. Let's look at this one. It says 10 years ago, the price of a 16-ounce bag of potato chips was $3.44. The current price of a 6-ounce bag is $4.74. Write a linear equation to represent the situation. So look, we're going to find M and we're going to find B, okay? So let's find M first, okay? What formula do we use to calculate the slope or to find the rate of change? What formula for slope? There are two formulas for slope. Does anybody remember what the two formulas for slope are? Gotta read over your notes. Yes, baby.
Y=mx plus b.
That's the slope intercept form.
Oh, right.
Okay, that's okay. That's the slope intercept form. What's the slope formula? Yes, baby.
Y2 minus y1 over x2 minus x1.
Very good. They're not going to give you the formulas. You have to know them by heart, okay? So y2 minus y1 over x2 minus x1. That's the formula for slope. The other formula for slope is rise over run. That's where you count from one point to the other. Yes, baby.
0x2. X2 minus x2.
Oh, thank you. Thank you, babe. All right. So now let's label our points, okay? Let's label our points and then substitute. This is our first point. This is our second point. So this is x1, y1, x2, y2. Okay? All right. Year, it's always going to be x, and total is going to be y. Okay? So let's substitute. All right. When we substitute, what are we going to put on the top? Y2 minus y1. What goes on the top? What minus what? Mm-hmm. $4.74. Very good, babe. Minus, very good, $3.44. Excellent job. What are we going to put on the bottom? What minus what? Yes, babe.
10 minus 0.
Very good. 10 minus 0. Okay. All right. Let me pause because you do need your calculator for today anyway. Rows 1 and 2, please pick up your calc. Okay. Let me clear my calculator. Second plus 7, 1, 2. And how much money did you say it was? $1 and what?
30 cents.
$1.30. And then what do we get on the bottom? 10. So we divide, right, to figure out what the price is every year. What did it go up by? Yes, baby.
Oh, 13 cents.
13 cents. Very good. So every year is going up 13 cents. Miss Reyes, how do you know it's going up? Because the number is positive. Okay. All right. So now let's find B. Yes, baby.
How do you get 0.13?
You divide it.
Oh, okay. That makes sense.
Okay. You're fine. If you don't know, you should ask. Okay. So that is okay. What's the starting amount here? What's your B going to be? $3.44. You see right here, this is the 0 year, the starting year. Okay, so the starting year, the price was $3.44. So now how do I use this to write the equation? Yes, baby. Excellent job. Did anybody get this right? Okay, you did. Good job. Okay, very, very good. All right, let's go ahead and take out our notebook, please, so we can finish correlation and causation. Anybody still copying this before I move it? Okay, I'll pause. Take out your notebook. All right, good people. Everybody should have. If you wasn't here yesterday, when I wasn't here, all the notes that she gave you, you need to number that page 16. Okay, did everybody do that? Make sure you number those pages 16. Okay. We're on page 17. This is where we started yesterday. Went over a little bit of the notes that was given when I was absent. And this is where we're picking up at. Correlation and causation. Correlation is the relationship between quantities in a scatter plot, the relationship between points. We talked about, you've already written notes on positive correlation, negative correlation, and no correlation, okay? Positive correlation is when the points are going up. On average, most of the points are going up. You can have a couple outliers, okay? It's okay, it's still positive. It's on an average, most of the points are going up. Negative correlation is when you have those points going down. As X increases, Y decreases. On an average, you can have a couple outliers, okay? And no correlation is when you can't, the points are all over the place. That means that the two variables you're comparing, they are very much unrelated. They have like a 0.2, 0.3, or negative 0.1, negative 0.2 R, okay? All right, so here's the scale that I was talking about. Correlation coefficient. That tells you the strength of the correlation. That tells you the strength of those two quantities, okay? All right. R is only going to be between -1 and +1. You can't have anything outside of that. Can't be 1.1, 2, 3, 4, -2, 3, 4. It has to be between, your R is going to be between -1 and +1. Okay? You just go. All right. 0 is when you have no correlation. The closer you get to 1, +1, the stronger the correlation is. Positive correlation. The closer you get to a -1, the stronger the negative correlation is. Any questions about the scale and how to read it? Okay. All right, good deal. Let's talk about causation now. The difference between correlation and causation. What is the difference between correlation and causation? All right. Correlation is a relationship between two quantities. They are related to each other. Okay. Causation is a cause and effect. Okay. Causation is a cause and effect. That means one of the quantities directly causes the other quantity to happen. They're directly related to each other. Not just the correlation, but they're related to each other. Okay? It directly affects the other variable. All right? So causation, when one of the quantities directly, this is super important, directly causes the other. Yeah, it's really causes. I don't want to say effect because it's really causes the other. The amount of money you make, the amount of money you make per hour, and the total pay that is causation. That truly directly affects how much you make total. Okay, the hourly amount. See, what's another one that is direct. Say again. Age and what though? Age and height. That it's not really causation because you got short people, you got tall people, all ages. Yes.
How much money you made in a week and how many hours you worked?
We said that one. Yes.
How far you drive and how much gas you use?
Yeah, that's a direct effect. It is. Anything else? You can't. What about this example? Tell me if you think it's just correlation and or because correlation and causation, a problem can be both. Okay, it can be both. There could be a positive correlation and causation at the same time. But just because there's a correlation doesn't mean it's always going to be causation. All right, so let's look at this one. Let's suppose that you have, I'm gonna do this one here. We got X and we got Y. Let's make our X the, oh, I don't know if I can use that example. Let's use desserts. I was gonna say something else, but we'll go with the more friendly one. Let's use the number of snacks that a person eats. Okay, number of snacks. I'll just leave it at number of snacks. And uh, number of people that have diabetes. That was dark, wasn't it?
Yeah.
Yeah, that was so wholesome for us.
I'm sorry.
It was like really quick.
Yeah, I'm so sorry. Okay, whatever. All right. So, do you think this is a correlation? Positive, negative, zero correlation. What are your thoughts? Positive correlation for the most part, not all the time, okay? But this would be a positive correlation. Okay? Is it causation?
Yes.
You think that
No.
the number of snacks a person eats?
Depends on what snack it is.
No.
You think
Depends on
so?
the snack and what's in it. If he said broccoli,
Well, like
so
sweets. Should I say sweets?
yeah, that makes sense.
Sweets. Okay. So do you think this is causation also?
Yeah.
Okay. This is causation. What about the example that I might use this example anyway? The amount of no, I better not. I won't record it.